Hello everyone, we are solving the first question. According to the figure, we have three components totally. First is semicircle, second is square, and third is also semicircle. So first semicircle, its area, the x bar value and y bar value. So for semicircle, area is equal to 628.3. X bar, as it's on x-axis, y-axis, the center is coinciding with y-axis, x bar is 0 and y is equal to 20 plus 8.4. Second part, for square, area is 1600, x bar is 0 and y bar is also 0 because it's in center and we are taking this is as origin. And third part is also semicircle with area 628.3. The x bar will be 0 and the y bar will be minus 20 plus 8.4 as it's below the origin. So for calculating the moment of inertia for composite figure, the formula is Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. So we are calculating the Iyy1, Iyy1. Formula is pi r to the power 4 divided by 8, which after calculating it comes equal to 6.28 into 10 to the power 4 millimeter power 4. This is Iyy1. So second Iyy2 is the formula for square. The moment of inertia of square is bh cube by 12. Here breadth and height are same. So after calculating the value comes equal to 2.3 into 10 to the power 5 millimeter power 4. As semicircle, both semicircles are similar, we can Iyy2 and Iyy3 will be equal. So the final formula for the whole composite figures moment of inertia will be equal to 2Iyy1 plus Iyy2, which is on adding up this and twice the value of this equal to, which comes 3.39 into 10 to the power 5 millimeter to the power 4. Now the moment of inertia about x-axis will be Ixx equal to Ixx1 plus Ixx2 plus Ixx3. Here again Ixx1 and Ixx3 will be equal, so we can write it as 2Ixx1 plus Ixx2. We are calculating Ixx1. For this we have to apply the parallel axis theorem. According to that, the moment of inertia about its own plus area into distance square. So the formula for moment of inertia about its own central axis equal to I pi power r power 4 upon 8 plus a d square. As this distance, the semicircle's central axis will be here, so this distance minus this distance, so we have to just consider this distance. So we are subtracting this distance from this whole distance. So the formula will be like pi 20 power 4 divided by 8 plus 628.3 to 28.4 power square minus this distance. So area 628 8.3 and 8.4 square. So this will give us ix(x1) equal to 5.28 into 10 to the power 5, and which is equal to ixx3. So now we are left with ixx2. The formula for it is nbq by 12, which comes on calculating equals to 2.13 into 10 to the power 5 mm power 4. So the whole moment of inertia about x axis equal to ixx1 equal to 2ixx1 plus ixx2, which comes equal to 1.27 into 10 to the power 5 millimeter to the power 4. Thank you. Hello everyone, we are solving the second question. The figure is this, which consists of 3 parts. One is square and 2 are similar semicircles which are cutted off. So first part is a semicircle, second part is square, and third part is semicircle. And areas are 6.6 to 8.3, 3600, 6 to 8.3. The x bar and y bar accordingly are 3, 8.4, first is 8.4, then for square it's 3, and semicircle it's third semicircle it's 51.6, and y bar are 0, 0, 0. So for moment of inertia of total figure, the formula will be ixx1 plus ixx2 plus ixx3. The first, the two semicircles are similar, so we can club ixx1 and ixx3. So the final formula will be, and these parts are getting cutted off, so we can write it as minus 2ixx1 plus ixx2. This is a square and this is for semicircles. So we are calculating ixx1. The formula will be 5 r to the power 4 by 8. The value will be equal to 6.28 into 10 to the power 4 millimeter power 4. So as ixx is equal to ix is 3, this is ixx3. Now for ixx2, the formula is bh cube by 12. Here it's square, so it will be, you can say that h to the power 4 by 12. So the after calculation it comes 1.08 into 10 to the power 6 millimeter. So the final moment of inertia about x-axis will be ixx is equal to minus 2ixx1 plus ixx2, which is on summation and subtracting, it comes equal to 9.54 into 10 to the power 5 and millimeter power 4. For moment of inertia about y-axis, as about above we did the same, y1 plus y2 plus y3. The y2 calculations are, the formula for that is bh cube by 12. This is which comes on calculation equal to 1.08 into 10 to the power 6 millimeter power 4. And for y1, the formula is pi as it's not center, so we are applying parallel axis theorem. For that, formula will be pi r to the power 4 by 8 plus area into distance from the composite figure's centroid to its semicircular centroid, its distance square. So the calculations will be 6.28 into 10 to the power 4 plus 6.283, which is area, and 21.6 distance square minus the distance of its own center from centroid. This is the effective distance. So 6 to 8.3 and distance 8.4 whole square. So on the final calculation, I by 1 comes equal to 4.57 into अरे इसको पॉज करो. So the I by 1 comes equal to 3.12 into 10 to the power 5. The final moment of inertia about y-axis is equal to I by y is equal to minus 1.08 into 10 to the power 6 minus 2 times 3.12 into 10 to the power 5, as these two semicircles are equal. So the final moment of inertia about y-axis is 4.57 into 10 to the power 5 millimeter power 4. Thank you.
Question 3. Consider rectangle as the first part. And triangle as the second part. The centroid of rectangle and triangle. Area of rectangle is 6480 and centroid x-axis is 54 and y-axis is 0. Triangle is 1296, x-axis is 46 and centroid is y-axis is 0. Centroid of whole figure is at 56,0. Now for about the inertia about the x-axis, you have to sum ix(x1), which is the inertia of first figure, and ixx2, inertia of second figure about x-axis. Ixx1 is equal to 1 by 12 into 108 into 60 cube is equal to 1.944 into 10 to the power 6, where ixx2 is equal to twice of 1 by 36 into 72 to 183 cube, 181 cube, plus half of 78 186 square, that is equal to 69.984 into 10 to the power 3. So inertia about the x-axis of the entire figure is equal to 1.944 minus 0.069984 10 to the power 6. That is equal to 1.874 into 10 to the power 6. And inertia of a figure about the y-axis can be taken as inertia of the first figure about the y-axis minus inertia of the second figure about y-axis. Inertia of the first figure about y-axis is equal to 1 by 12 into 60 into 188 whole cube plus 6480 56 minus 54 whole square, that is equal to 6.324 plus 10 to the power 6. Inertia of the second figure about y-axis is equal to 1 by 36 into 36 into 7 to 2 power 3 plus 1296 square 56 minus 54 whole square, that is equal to 0.502 into 10 to the power 6. Inertia of the figure about the total inertia about y-axis can be written as 6.324 minus 0.502 into 10 to the power 6, that is equal to 5.82 into 10 to the power 6 and 4. And got the second question. निकालना second question. So on the fourth question, the figure is this. We take the first part as the triangle and the second part as the rectangle. Origin is this. Now the figure consists of two parts, rectangle and triangle. These are the centroidal axes of rectangle and triangle. Area of rectangle is 264 unit square and triangle is 216. Centroidal axis of rectangle is 11. On the fourth question, we have the two figures. First figure is a triangle and the second figure is a rectangle. So rectangle, for the rectangle we have the area 264 and the since the curve is symmetric over the y-axis, so there will be the variation about the figure. Inner centroidal point will lie on the y-axis. For the rectangle, area is 264, y bar is 11, and for the triangle, area is 216 and y bar is 28. Multiplication of y bar and 8. Summation of area 480 of y bar a is 8952 and y is 1 plus ix2 ix1 1 by 12 into 22 cube plus 264 18.65 minus 11 whole square, that is equal to 26098 mm to power 4. Inertia of x-axis of the second figure is 1 by 36 into 10 to 24 into 18 cube plus 216 bracket 28 minus 18.65, that is equal to 22,771. X is equal to 38.9 into 10 to the power 3. The inertia of the figure about y-axis is equal to inertia of the first figure about y-axis plus inertia of second figure about y-axis, that is equal to 1 by 12 into 22 into 12 cubes, that is equal to 3168. Inertia of the second figure about y-axis is equal to it is equal to 3888 mm to power 4. So summation of these both.
Hello everyone, so today we are going to determine the moment of inertia Ix and Iy of this figure. So today we will make a table. Area, X bar, Y bar. These are the shapes which are present in the body. Rectangle 1, rectangle 2. Okay. So area of rectangle 1 and rectangle 2. For 1 it is 40, for 2 it is minus 10. And the center with respect to X for 1 and 2 is 2.5 and 1.9. And about Y it is 4, and for rectangle 2 it is 4.3. So for calculating the centroid, so you need to calculate X bar A, Y bar A. So X bar means this into this, X bar A. So 100 and this into this minus 19. And for same for this, so here it is 160 and 43. So for calculating the centroid, this is the formula: X bar A summation upon summation area. So it comes 81 by 30, so 2.7. For Y bar, it comes area of this 117 upon 30, so it comes 3.9. So for calculating moment of inertia about x-axis, Ixx1 plus Ixx2. So moment of inertia of first rectangle, this is moment of inertia of second rectangle. So Ixx1 by using parallel axis theorem, bh cube 12 up ad square. Okay, so base is this, so base is 5 and height is 8, so whole cube plus by 12, this is the formula. And for this area is 40, and the height means difference between this and this, so it comes 1.1 square. So moment of inertia comes 213.77. Let take millimeter 4, take millimeter. And for rectangle 2, bh cube by 12 plus ad square. And for rectangle 2, this, so breadth is 2, height is 5 cube by 12 plus area 10, and a difference between the x, this is 0.4, so square, it will come, this solving this, it will give 20.83 plus 1.6, so adding up it gives millimeter. So we need to minus this from this, so Ixx is equals to Ixx1 minus Ixx2, so 213.77 minus 22.43, it comes 191.34. This is the moment of inertia about x-axis. So for y-axis, Iyy, same procedure. So Iyy1 is equals to moment of inertia about x is of rectangle is bh cube by 12. For this it is hb cube by 12 plus ad square. Just reverse it. So 8 5 cube by 12 plus 40 into 20 d square. This d is the difference between y of this and y of this, so it comes 84.93 millimeter 4. For Iyy2, same, hb cube by 12 plus ad square, 5 into 2 k cube, just reverse it, plus area is 10 and this d is 8.8, so it comes 9.73. So for Iyy, this is Iyy. So we got Ixx as 191.34 and Iyy as 75.2. Thank you. So this is problem number 6. So there are mainly 3 shapes, 1 2 3. So rectangle 1, rectangle 2 and rectangle 3, and the area of these rectangles 1.3, 1.9, 1.8, and the center of these with respect to x and y 0.65, 4.8, 0.25 for rectangle 2, 2.4, 1.8, 0.25. So we need to find the centroid of whole figure. So for that formula we need to calculate x bar a and also the y bar a. X bar a is the multiplication of a with respect to x bar, and for y bar a with respect to y bar. So 8.45, 0.475, 3.24, and with respect to y 6.24, 4.56, 0.45. So for calculating the centroid, this is the formula: x is equals to summation of x bar a upon summation of area. So x bar comes 0.912 after adding this and total area. So for y, summation of y bar a, summation of a. so this comes 2.25. Now we need to calculate the moment of inertia about x-axis. So Ixx is equals to Ix1 moment of inertia of rectangle 1 plus Ixx2 moment of inertia along with respect to 2 about x, Ixx3 moment of inertia about x of this rectangle. So for Ixx1, bh cube by 12 plus ad square. So b is 1.3 into 1, 1.3 into 1 upon 12 plus area is 1.3, and d is the difference between the centroid and the position of x of rectangle 1, so it's 0.65, so the difference is 2.55, so we need to square. So after calculating we get 8.656. We are taking millimeter. For Ixx2 for rectangle 2, bh cube by 12 plus ad square. So for rectangle 2, the breadth is 0.5, this is 0.5, and height is 3.8. So 0.5 cube 3.6, and area is 1.9 and 0.15 whole square. D is 0.15 whole square, and this should be 38 cube. So after calculating, we get 2.2863 plus 0.04275. So summing up, we get 2329 millimeter 4. For Ixx3, bh cube by 12 plus ad square. So this is 3.6 and this is 0.5. So 3.6 0.5 cube by 12 plus 1.8 into 2 square. We get 7.2375. So moment of inertia whole of the figure is Ixx is equals to Ixx1 plus Ixx2 plus Ixx3. It will come 18.1265. So about y-axis, Iyy is equals to Iyy1 Iyy2 plus Iyy3. So for Iyy1 is equals to hb cube by 12 plus ad square. So we need to just reverse it and just cube it. 1.3 by 12 plus 1 by 3 into, and here d will be the difference between x of centroid of that figure and the whole of the centroid. It's the difference between them. So after calculating we get 0.183 plus 0.0892. We get 0.272 millimeter 4, and for Iyy2 this should hb b cube by 12 plus ad square. It will come 3.8 into 0.5 cube by 12 plus 1.9 into 0.662 का whole square. So we get 0.8715. For rectangle 3, about y, moment of inertia, hb cube by 12 plus ad square. So 0.5 into 3.6 cube by 12 plus 1.8 into 0.88 का whole square. So we get 1.944 plus 1.4193. So on adding up iyyy1 plus iyyy2 plus iyyy3, we get 4.51 as moment of inertia about y-axis. Thank you.